This session has been designed in order to keep you alive and energized, because we will talk about digitalization in manufacturing. Why this is so important for you? Because digitalization is the key for truly understanding how my production is performing. And because digitalization also supports to improve our GMP compliance, the compliance with the regulations. But I also know that some of you is thinking, how can I apply digitalization to my existing equipment? This is exactly one of the topics of today, integration of legacy equipment. We will have real use cases from life science industries, and also we will have a contribution from the ISPE, the International Society for Pharmaceutical Engineering. And I want to start this session with a small quiz. I'm an old school engineer. And when I began my career, this was considered a portable computer. Yes, portable. More than 15 kilograms. Can you imagine carrying this stuff on a plane trip just to fix a problem on the customer side? So, who actually remember this? Who actually use it? Hands up. Wow, okay. Many veterans here, eh? Many veterans. Very good, very good. So this was back in the 90s. And you know what? This portable computer was not Linux, Windows, MS-DOS, was CP/M, another operating system, and was used for programming this legendary PLC, the SIMATIC S5. And you know what? We're still finding this PLC in some customer, in some plant. And we still need to connect it. Recently, I came across an article in Forbes. It was reporting a survey conducted by Salesforce to more than 500 business leaders in US. And one of the questions was, how much do you trust the reliability of the data feeding your AI systems? Back in 2023, when this question was asked, 54% of the respondents said, yes, I trust in my data. Not a big score, actually, but at least more than a half, they said, yes, I trust in my data. The same question has been asked at the beginning of this year, in 2025. What happened in between 2023 and 2025? Well, quite a lot, actually. Eh? We had a war just 1,000 kilometers from here. We have some political changes in the US. We have the Holy Land on fire again. And probably as European, we realize that we do something better in the direction of European Union. But this is out of topic, of course. What happened in the area of digitalization? We had, let me say, the revolution of generative AI, ChatGPT and all its friends. Well, in your opinion, How should be the trust in the reliability now if we ask the same question to the business leader in the US? More than 54, less than 54, or maybe it's constant? More. Okay. Well, the reality is that only 40% of the business leaders said, I trust in my data. So dropped from 54 to 40%. Why? How this should be possible? One of the answers is that generative AI, with all its magic, let me say, but also with some occasional wrong answers or hallucinations, really highlighted the problem. The problem is that if I don't have reliable data in input, the output can never be trusted. In other words, garbage in, garbage out. This is the article in Forbes, and this is the link for the report. I suggest reading this article. It's not long, and I think it can provide you some insight. And this brings to me to the first takeaway. Reliable data is the foundation of digital transformation. If we don't have reliable data, we can forget digital transformation. Now, if we think to a manufacturing plant, let's imagine we are a pharmaceutical company. What means reliable data in a pharmaceutical manufacturing? Well, I'm a pharmaceutical company, so I need to comply with GMP regulations. So reliable data means improving data integrity, means providing the right data to an electronic batch record, means having better quality controls. But not only. Maybe I need more information in the area of business improvement. For example, I want to provide data to my process development guys, or maybe improve my process optimization, OEE, for example, or reduce my consumptions. All those features needs data from the manufacturing area. So today, we are concentrated on this bidirectional arrow. Bidirectional arrow. And let me offer you an example. What means, for example, in providing data to the electronic batch record? Let's try together to understand this idea. I need, for example, to provide so-called time series data. So it's, for example, a temperature that is critical for me, and I want to see the temperature trend. You can say, okay, this is not rocket science. This is true. But what happens if you, for a network issue, lose data? What happens with your batch if you lose data? So you need a system capable to buffer your data and to store and forward the data in case of network disconnection. Second, you need aggregated process values. For example, I have in front of me a granulator. I am in a granulation phase, and during the mixing phase, I want to know at the end of the unit operation, minimum, maximum, average, and standard deviation for the temperature again. So aggregated data. And this is different from time series data. You need some data aggregation job to do during the data acquisition. But then your machine maybe produce critical alarms. And critical alarms are relevant for my electronic batch record. And maybe my operator is changing some parameter on the machine, a critical process parameter. And I need to track these changes in my audit trails. All those changes are exceptions. And if I want to provide the exceptions to my electronic batch record because my EBR want to do the review by exception, this is relevant. And finally, I want to synchronize the execution of the electronic batch record with my machine execution. What does it mean in this case? Again, an example. When I start my production, I need to send to my machine the batch context, the batch ID, the product name, the recipe and the version I need to load in my machine, for example. During the production, I need to perform some in-process control. So I need to check the quality of my production. And again, communication between MES, EBR in MES, and my machines. And at the end of the production, I need to send back some counter, some data. This is exactly an example of bi-directional communication. This is an example of transactional communication. I hope that you understand that collecting data is not just a matter to acquire data and then someone will take care to it. During the acquisition process, you need to do some job with the data. And the communication must be bi-directional. But if this is the request from the EBR, what is the reality in your manufacturing sites? The reality is that you have machines from different suppliers. Each machine provides a specific unit operation, but each machine builder decides what PLC you want to use, what SCADA you want to use, because he prefers one vendor or another, and so on. But now you need to connect the machines, because you need the data for audit trail, alarm, historian, and so on. If you ask to your machine builders, please give me your data, they provide you the data, for sure. But each machine builder has a known standardization for the data acquisition, for the data interface. Today, more or less, all the machine builders provide you real-time data using OPC UA. But what about historical data? What about alarms? What about audit trail? Someone provides you the data in a SQL server, someone in a CSV file, someone in XML file. So at the end of the day, you have custom interfaces and incompatible technology. And what does it mean? It means increase of cost in integration and in validation. So you need to spend money for integrating a machine. You need to spend money for validate the interface, because we are in GMP critical environment. This is why, since some time, one of the ideas is to create a middleware in between OT and IT. In COPA-DATA, we call it automation integration layer. The automation integration layer is a solution based on a zenon software platform that provides exactly this job of bridging OT with IT. Of course, one of the main goals is ensuring compliance with data integrity and the GMP regulations. And in one side to the, let me say, machines and IT. And it provides bidirectional communication. Yes, bidirectional communication in both, again, OT and IT. And has the capability to contextualize the data, to aggregate the data, to provide exception handling, so alarming, or onboarding, ingesting audit trails from machines file, and provide historian capability, reporting, dashboarding, and so on. Someone can say, okay, yes, I can use Zenon, but I can use also other solutions. For sure, this is true. But what are, from an engineering point of view, the main pillars? First, Zenon is a no-code, low-code software platform. So it means that it's considered a category 4 software according to GAMP 5. It means using pre-configured functionalities that you can, of course, use or not use. This means reduction in engineering time, reduction in validation. The second pillar is modularity. What modularity means in this case? Modularity in software and in hardware. In software, in Zenon, you can develop templates. For example, I want to develop a template for a specific machine type. Centrally, I can develop it. I can test all the functionalities. I can then validate and release it and reuse it as many times as I need in the same company, in the same plant, or maybe in a different plant because I have different similar machines in different plants. This is the concept of smart objects in Zenon. But modularity is also in the area of hardware architectures. In Zenon, you can start small with a limited configuration, connecting few devices, and then you can extend, scale out the capability of the system, adding more edge components, more Zenon service engine to extend your connectivity. Modularity offers you flexibility. Modularity offers you the possibility to also work centralized and then deploy the solution to other automation team locally. And the third pillar is connectivity. Zenon connects OT and IT without third-party software. Connectivity is integrated in the platform. And we still connect SIMATIC S5 PLC, as we have seen in the beginning, and some of you already know. From the OT. From the IT, Zenon provides interfaces. For example, we have a certified interface for the communication with Verum PASIX. But not only PASIX, it's also, for example, for standard IT interfaces like GraphQL, REST API, and so on and so forth. So, these three pillars make Zenon automation integration layer an interesting solution for integrating legacy equipment, but also, of course, new machines, because Zenon also supports plug and produce standards like MTP, as we have seen this morning. But it's a perfect solution for the OT-IT integration. So, how we can produce reliable data? We have seen from Francesc that it's possible. It's possible to integrate existing machines in a reasonable time using the right tools. But it's not only a matter of technology and software tool, it's above all a collaboration between companies and people. From Henrik, Novo Nordisk, when buying new machines, specifying in the user requirement specification quality and efficiency of the machine is for sure important, but this is not enough. You must go also deep in the digital integration capabilities of the machine and guide your supplier toward a shared solution. It's more work at the beginning, but for sure, less effort after when you need to integrate the machines. And the job Henrik does with this book is this guide is very interesting in my opinion. And finally, from Rod and Thomas, we have just seen that ISPE is supporting MTP, is also with the great support from our lead, Josef Trappler, is the chair of the ISPE Pharma 4.0 Plug and Produce, and it's a very important message for the audience. So we can go with confidence in the direction of MTP. Finally, we started our presentation with the garbage in, garbage out, if you remember at the beginning. But today we have seen that with the collaborations, standards, and the right tools, we can change that story. Let's work together, and by 2027, meet again, having reversed that trend, proving that reliable digitalization is the foundation for building trust in the data. And let's also hope that by 2027, we'll come back together here or in another place, but in a world with a bit more in peace and a Europe a bit more united. Thank you.